Take a deep breath. Just one breath of yours contains 56 stillion atoms. Your body, 7 octillion. The observable universe, a 1 followed by 82 zeros and atoms. Mind-numbing numbers. But what if I told you that the infinity you know is just the first rung on a ladder that never ends, and that mathematicians have already mapped, or try to map, what lies after it? Prepare for a journey where logic bends, reality warps, and the most fundamental concept we know, infinity, reveals itself to be plural. You are about to face the greatest frontier of human thought. What, in fact, exists beyond infinity? For centuries, infinity was an impassable barrier, a wall that neither mathematics nor philosophy dared to fully cross. Think of Zeno's paradoxes 2,500 years ago. To go from point A to point B, you must first traverse half the distance, to cover the remainder half again, and so on infinite divisions. You would never reach your destination if you followed this logic. Or what about the infinity at the center of a black hole? A singularity, where density is so extreme that physics simply breaks. The laws of nature cease to exist. But what terrifies us in physics and philosophy, the concept of something without limit, was actually unraveled in mathematics. Curious hints. The infinity of positive integers, 1, 2, 3, is smaller than the infinity of numbers between 0 and 1. It is possible to have a hotel with infinite rooms fully occupied and still manage to host one more guest, freeing up infinite empty rooms in the process. They don't call it a larger infinity, but rather transfinite numbers. These facts force us to redefine everything we thought we knew about the largest possible number. Infinity is merely a starting point. Let's unlock the cosmic hierarchy of infinities. For most of us, infinity is the end of the line. But the German mathematician George Cantor, in the 19th century, dared to question this unity. He realized that infinity is not a singular concept, but rather a collection of sizes. He was the first to prove, rigorously and devastatingly, that there are infinities larger than others. Cantor called the smallest type of infinity the size of a set of natural numbers 1, 2, 3, 4, Aleph, no. A set is countable if you can put its elements into a list, even if that list never ends. The set of even numbers 2, 4, 6 is infinite. The set of negative integers, -1, -2, -3, is 2. Hilbert's hotel paradox illustrates Aleph, no, a hotel with Aleph, no rooms, all occupied. A new guest arrives. The manager simply asks every guest to move from room N to room N plus 1. The guest in room 1 goes to 2, the one in 2 to 3, and so on. All infinite guests move, and room 1 becomes free. The addition of 1 to Aleph, no, results in Aleph, no. This is why it is the smallest infinity. But Cantor didn't stop there. He asked himself, what about the real numbers? Those that include all fractions, repeating decimals, and most importantly, the irrational numbers, with infinite digits after the decimal point like pi. Using an ingenious method called the diagonalization argument, Cantor proved that no list, no matter how infinite, would ever manage to list all real numbers. You could always construct a new real number that wasn't on the list. This means that the set of real numbers is uncountable. Its size, the cardinality of the continuum, is greater than Aleph, no. It is an infinity that is genuinely more vast than the infinity of integers. Aleph, no, is an infinity of isolated points. The continuum is an infinity of lines, surfaces, space-time itself. Where Aleph, no, is the infinity of almost, the continuum is the infinity of totality. If Aleph, no, exists and the continuum exists, what comes next? In set theory, the size of an infinite set is given by the number Aleph, no, Aleph-1, Aleph-2, and so on. Cantor conjectured that the next infinity in the hierarchy after Aleph, no, would be Aleph-1, and he raised the famous continuum hypothesis, which states that the continuum is exactly equal to Aleph-1. In simple terms, there is no infinity of intermediate size between the countable and the set of real numbers. And if that is true, what is next? The next infinity would be Aleph-2, the size of the set of all subsets of the real numbers. And then Aleph-3, and so ad infinitum. The ladder of infinities is itself infinite. It is not just infinity, but an infinity of infinities, each dramatically larger than the last, the smallest of which is infinity that has challenged us for millennia. Since the Pythagoreans, c. 530 BC, real infinity was demonized. They sought order in rational numbers, which could be written as fractions, and considered the irrationals in the concept of real infinity as evil and defined by darkness. They believed that everything in the universe should be rational and limited. The idea of an actual infinity, an infinity that exists as a complete entity, and not just in potential, like a count that never stops, was an affront to their doctrine. George Cantor's discovery was not well received. Quite the opposite. He suffered virulent attacks from his contemporaries. Henri Poincaré, another giant of mathematics, called Cantor's theory a serious disease that would one day be expelled from mathematics. Leopold Kronecker, his former teacher, relentlessly persecuted him, calling him a scientific charlatan and a renegade. This overwhelming pressure, which confronted fundamental beliefs about the nature of reality and divinity, led Cantor to suffer multiple nervous breakdowns throughout his life, culminating in his death in a psychiatric hospital. The very concept of infinity was so disturbing that it literally drove a genius to madness. Modern physics confronts us with infinity in the cosmos. The observable universe is 92 billion light years in diameter. But what about the real universe? If the measurements showing the universe is flat and not curved like a sphere are perfectly correct, the universe may be infinite in extent. But there's a twist in the cosmology insider knowledge. The surface of the Earth is finite, but borderless. You can walk forever and return to your starting point. Cosmologists propose that the 3D universe could be curved in such a way that it closes in on itself like a multidimensional donut or cylinder, being finite yet boundless. What lies after the end of the universe would be, ironically, the beginning. Now, we return to the core question. What is after infinity? Aleph, null, and even after the continuum? In mathematics, there's an even more terrifying concept, the absolute infinite. Cantor gave a theological name, the Hebrew letter Tav, symbolizing the totality of God. It would be the infinity of all infinities, the largest conceivable number, the set of absolutely everything that is, exists or can exist. But there is a problem. A set that contains all sets, including itself, leads to Russell's paradox and a failure of logic. Mathematicians had to impose a rule that avoids this chaos, relegating the absolute infinite to a realm they call inconsistent, something so vast that it is impossible to be handled within the rules of mathematics. So, what would the absolute infinite be? It is the point where mathematics surrenders. It is the place where physics yields to metaphysics. It is a final frontier that not even Cantor's intellect could cross without paying a terrible price. We live in a universe where the count of everything is only the smallest of infinities. Above us, there's a ladder of transfinite numbers, Aleph-1, Aleph-2, Aleph-3, climbing infinitely. And above all that, perhaps the absolute infinite, Tav, the totality of God, a number that is forbidden to be computed. But what if your concept of infinity is too small? In 2025, mathematicians from the Vienna University of Technology and the University of Barcelona announced the discovery of two new levels of infinity, the rigid and ultra-rigid cardinals. They possess stronger properties and superpowers that break traditional patterns, interacting in ways that the mathematicians themselves describe as strange with the already known notions of infinity. They don't fit perfectly into the Aleph hierarchy. They are, in essence, infinities that defy the organization of infinities. This means at the moment you thought you had reached the end of Cantor's ladder, it branched into dimensions we never imagined. What is after infinity? It is not nothing. It is more infinity. And now, new types of infinity, forcing us to rewrite the rules of the game. The greatest mystery of the cosmos may not be what happens inside it, but what limits it or the absence of limits. If the human mind itself can conceive of infinity of infinities, what must reality contain to support such vastness? And what will happen when mathematics inevitably maps the next level of infinity? In the next episode, we will dive into multiverse theories and how the existence of an absolute infinite may mean that all possible realities already exist in an eternal loop. Are you ready to face level 2 infinity?